Hi guys, I am creating this video in order to share my personal experience for SWE intern interview in Arcesium. So everything in short, there were in all 5 rounds. Specifically in this video, I'll only be covering the first round, that is coding round. The rest of the rounds I'll be covering in upcoming videos. In case you guys are interested, you can subscribe this channel as I'll be posting videos on various interesting learning stuff as well. Now, details regarding my college and other information, in case you are interested, you can explore on yourself. I'm not covering as part of this video. Coming back to the current context, I'll start with round one, that is coding round. I'm not sure like when RCCM visited our campus, though this coding round was initiated on 23rd July 2022. There were in all two coding questions, 20 aptitude questions, and 20 CS subject questions. I don't remember like how much time duration was allocated to all of these tasks, but what as far I remember, like it was around 1 to 1.5 hours. So, regarding this 20 aptitude questions and this 20 CS subject questions, they were not quite simple. Uh, like solving them in the given duration of time was a bit tricky. Regarding these two coding questions, they were quite simple, and like in case you guys are doing competitive programming on a day-to-day basis, then it will be very easy for you to solve these kind of problems. It was sort of easy to medium kind of problems. Now, talking about the these two coding questions specifically, coming on to the first question. So it was like a company has n offices connected by n minus 1 fiber optic cables. Now the goal is to place minimum number of supervisors so that every cable is covered. Now this question is not complete in itself. I'll explain you what does this mean. Let's say we have these many nodes and these are the edges, which we say as fiber optic cables. Now on each node you need to put a supervisor, not each node, like you need to put the supervisor optimally so that the number of supervisors you put are minimum, and the other information which is important in this question is each supervisor can cover the directly connected fiber optic cable to that node. For an example, if you put a supervisor here, uh, he'll be able to cover the fiber optic cable, this one and this one. In case you put that supervisor here, he'll be only be able to cover this guy. So you need to put the supervisors in an optimal fashion. I'll not be telling the full solution of this problem. I'll just be providing the hint. As you guys can understand that it's a basic DFS plus dynamic programming based problem. You just need to perform the DFS and with the DP states as this DP of V 0/1. Now, what does this mean? DP of V0 means, let's say this is the Vth node. Okay, what does DPV0 mean? It means you are you're not putting a supervisor on this node. Now, if that's the case, then what can be the minimum number of supervisor within the subtree under this Vth node? Okay, precisely what will be the answer under this subtree if you don't put the supervisor here? And dp of v1 means You are putting the supervisor here. Now, what will be the minimum answer? The final answer here will be, if you can understand, minimum of dp of a root 0, comma dp of root 1. In case you guys are not understanding, you can think more or watch this video twice, or maybe you can ask specifically in the comment section as well. Okay, going to the second question. Now, you are given two arrays A and B of length n. For each index I, you need to find the smallest subarray starting from I that has at least bi elements with value greater than ai. What does this mean? Basically, you are given two arrays, A and B. Okay. Let's say AB somewhat like 8, 9, 1, 2, 3. So for each index I, okay, let's define B as well. 1, 2, 1, 3, 1. So for each index I, you need to, uh, you know, uh, given the result set, that what will be the minimum subarray length mm, for, having all number of elements greater in that specific subarray less like greater than or equal to bi. For an example, if I is 0 here, right? Then ai is 8. Now you need to find a smallest subarray such that in in that subarray the number of elements greater than or equal to 8 is 1. So this is the minimum subarray for this guy. For 9, there is no such subarray. So for that, you need to print, -1 in your result set. So answer will look like, you know, uh, 1 for this one. For this one, it will be -1. For this guy, it will be 1. For this guy, -1. For this guy, 1. Length will be 1. Okay. Hope you understood this problem. So again, this problem can be solved using policy-based data structure, which is similar to set. In case you are knowing that we have some sort of, data structure that is PBDS in C++ STL only, you can easily solve this problem. You can explore more on that in case you are not aware of this PBDS. Now, aptitude questions, I already mentioned that there were 20 questions. These were the topics. Okay. Regarding CS related questions, topics from where I got the queries were, operating system, DBMS, computer networks, DSA. In case you are guys like well versed with these topics, then these questions were easier only to hit. Now, key takeaways from this specific video are, like, in case you are having strong DSA preparation, then you can make sure that you are completing those two coding problems uh, in very short durations so that you can give more time on those aptitude and that CS related queries. Okay. So these 2 points are very specific for this video only. not specific for that interview preparation. So like being comfortable with the trees, DFS, sliding window, policy based data structure, and advanced STL usage helped specifically in this round one. Okay, that's it for this video. In case you guys have any queries, you can post in the comments. Thanks, guys.